Morning, people. I hope you're doing well, my delovelies, so let's lay in something that may contain science. And coffee. It leads to surprisingly concrete science, but we'll get there. People drink about 2 billion cups of coffee every day. I can't understand that because I have a palate as sophisticated as a first grader's, but apparently there's plenty of people around the world who enjoy what I cannot, and I'm not here to yucky yum. But after you've run the water through the coffee and all that, you're left with the grounds. Some people use those grounds in compost and fertilizer and so on, but most of those coffee grounds are left in a landfill to decompose and let off methane and carbon dioxide and generally just sit there being worse than useless. Well, what if they sat somewhere else? Somewhere they could be helpful. Researchers at the Royal Melbourne Institute of Technology wanted to make better use of these coffee grounds. As co-lead author Dr. Shannon Kilmartin-Lynch points out, finding more effective use for wastes like these, quote, from an Indigenous perspective, involves caring for country, ensuring there's a sustainable life cycle for all materials, and avoiding things going into landfill. So, on the one hand, we've got a material we want to make use of. Used coffee grounds. On the other hand, at our MIT, we have engineering expertise. Materials engineering, specifically in concrete. And I can only imagine it's because the challenge and the expertise coexisted at the same technical institute that anyone thought of the idea of putting coffee into concrete. 'Cause it's certainly not a combination that would have come immediately to my mind. Our engineers scoured Melbourne for a supplier for all the coffee they'd need, ultimately partnering with Indigenous-owned Tawali coffee roasters. With their spent coffee grounds in hand, the next step was to figure out how they fit into the formula of concrete. The essential ingredients of concrete are cement and water. Cement is made from ground limestone, clay or shale, iron, and sand. It's mixed, put in a kiln, heated to 1600 degrees Celsius, 2912 degrees Fahrenheit, and then you have something that can crystallize when it interacts with water. Concrete looks like it's drying, but actually it cures. For as long as there's water and unreacted cement, it can continue to cure, and that process can carry on for years, even if it seems for all practical purposes like your concrete's pretty much done. But that's like making ice cream out of the cream, egg yolks, sugar, and salt. Yes, technically, that is everything you need for ice cream. But no one ever just makes the base without putting anything in it. About 60 to 80% of concrete is the metaphorical vanilla extract or what have you, called aggregates. Most concrete will have sand and gravel in it as the bulk of the aggregate, although in some cases you'll use other minerals. Finally, there's the admixture, the chocolate chips and other toppings of our metaphor. Those are application-specific additives that tune the concrete mixture for a particular use or requirement, like accelerating or slowing cure times. Since I've been talking a lot about coffee and I've been comparing ice cream to concrete, alright, I do feel compelled to say that May Contain Science does not endorse eating concrete. Please do not. But both in our ice cream metaphor and in our innovative new concrete, coffee is an aggregate. At first, our engineers tried putting the coffee grounds raw directly into the concrete, and long story short, it did not work. The coffee was a weak aggregate and basically got in the way of the cement and water hydration reaction, so they tried a different method. Our researchers took the coffee grounds, dried them at high heat, then subjected them to pyrolysis, high temperature in an oxygen-free environment that causes the long-chain organic molecules to vibrate and break down. The result is biochar, which isn't quite charcoal, but it's definitely charcoal's more sophisticated cousin. After extensive testing, our team found that the ideal mixture involved substituting 15% of the fine aggregate, so the sand of our sand and gravel aggregate with coffee grounds. Now, we didn't have weak concrete. The best version they tested, the 15% aggregate substitution, actually improved the compressive strength of the concrete by 30%. Compressive strength is already a strength of concrete. It's tensile strength that requires concrete to be reinforced with steel and stuff like that. But this demonstrated that coffee concrete definitely wouldn't make for weak concrete. In fact, anything but. The coffee biochar actually enables the concrete curing process we just talked about. Coffee biochar is porous and permeable, where sand is not. So, when the concrete is wet, the coffee traps moisture. As the concrete cures and dries, the osmotic balance changes, so the coffee releases the moisture back into the surrounding cement. Because concrete continues to cure as long as there are unhydrated components and water, the released moisture from the coffee allows the concrete curing reaction to continue. The result is a more robust cure and hence stronger concrete. Since it's replacing some of the aggregate we usually use, coffee ground aggregate doesn't just get the coffee waste out of our landfills, it also provides environmental value by substituting a fraction of the sand that goes into our concrete. If 2 billion cups of coffee are consumed every day, 137 million tons of natural sand are used in construction projects every day as well. There's a lot of sand in the world, but not all of it is suitable for construction, and we're genuinely running out of the kind of sand that's used for fine aggregate and concrete. Even with all of our coffee grounds going into the ground, we're not going to solve our sand shortage. I mean, do the math on 2 billion daily cups of coffee and 137 million daily tons of sand. But it's always nice to address two environmental problems at once. And this isn't even the first time that this group has looked at material waste and said, I bet we could make concrete out of that. Engineers from this same group have enhanced the mechanical properties of concrete using single-use item waste like face masks and medical gloves, which is probably more practical than making grape soda out of latex gloves like Nile Red did, even though it's also less awesome YouTube content than making grape soda out of latex gloves like Nile Red did. Since these items would otherwise sit in a landfill, decomposing and letting off carbon dioxide, by sticking them in concrete, you allow for carbon mineralization, in which carbon dioxide becomes a solid mineral like carbonate, calcite, or magnesite, and can no longer return to the atmosphere as a gas to continue to contribute to carbon emissions. Is concrete itself ideal? Well, a city block of trees will always do more for the environment than a city block of concrete. But a city block of coffee concrete may prevent an additional city block of coffee grounds in a landfill with all its attendant emissions. All of this research is in early stages, and the team is looking for local partners willing to field trial the coffee concrete. Ultimately, the hope is that organic materials beyond coffee, other organic waste like food and agricultural waste, may be usable for biochar and concrete construction as well, which would further decrease our reliance on natural sand by providing us with a larger supply of fine aggregate than what coffee alone could provide, and thereby go a much longer way to reducing carbon dioxide and methane from decomposition in landfills by sequestering it instead. They always tell you that necessity is the mother of invention, and we're definitely interested in inventing novel ways to address our environmental problems, but it seems like coffee's the worldly wise big sibling that enables invention. Maybe my little kitty palate needs to try a cup.